was mentioning while we were looking at the notes, if on any of the denominators you can factor something, you should try to do that. So what I'm going to do here, I'm just going to leave that first fraction and that second fraction alone because there's nothing I can factor. But could you factor the denominator of the fraction that these two added together, like the 8 over x squared minus 121? Can anybody just raise your hand and tell me how you would factor the bottom of that? You got x squared minus 121. Yeah.
X plus 11 and x minus 11.
Yes. X plus 11, x minus 11. Okay, now, if I want to make all the denominators match, I kind of have a partial in each of the ones that we already wrote down, right? So this one is missing the x plus 11. And this one is missing the x minus 11. And the third fraction already has that denominator. So if I make them all match, then you can just cross that denominator right on out, because if you make all the denominators the same, when you actually add those fractions together, they'd keep that common denominator, forces all those numerators to be equal. Now, you got to do a little distributive property, but you can do that. So we'd have 5 times x plus 11, so I'd have 5x plus 55. This is actually just going to be distributing a 1, so it'll just keep those terms the same. So 1 times x would be x, 1 times negative 11 would just be negative 11, and then you're equal to 8. So, bless you, I got 6x, I'm just combining like terms, plus 44 equals 8. So then all we're going to do, we're going to subtract 44. Let's see what that is. We're going to get 6x. If you subtract that, negative 36. X would be, whoops, negative 6. Now, the only two numbers that would cause you a problem, you don't have to write this down, but let me just back up real quick. The original problem, if we were to write restrictions for that, we'd say x can't be 11 or negative 11. So as long as I don't get one of those numbers as my answer, we should be totally fine. So just negative 6 should be your answer there. Anybody have a question? Okay. Can anybody factor for me? If I have x squared plus 17x plus 72, can you think of factors of 72 that add up to 17? Yes, x plus 8 and x plus 9. Now, if you look at the other side, we have this 3 over x plus 8, so I already have one of the factors. So to make that match, this would need an x plus 9, top and bottom. And my other fraction, we had x plus 2, and we had an x plus 9, so that one, to make a matching denominator, is missing an x plus 8. Now, this one is obviously a little trickier because on the top of this fraction, I'm going to have to do a FOIL because I've got an x plus 2 times that x plus 8. But if I make all those denominators match, we don't have to worry about that. All right, well, I wrote too big here. Let me see if I can space this out. So this side, we just have 7. I'm going to do a little distributive property. So we're going to get 3x plus 27. And let me grab a different color. I'm just going to kind of FOIL this right above, but I'll put the simplified version down below. So we'd have like a FOIL or box, whichever one you like better. So I've got x times x, so x squared, x times 8, so I got 8x, 2 times x, so I got 2x, and 2 times 8, so I've got 16. If you actually combine the like terms there, we'd have x squared plus 10x plus 16. In term, that's what's going on when I get that FOIL. So we do have a quadratic here. So I would want to set this equal to 0. All right, I'm going to put the x squared first. See how many x's I've got here. I've got 10 here, and I've got 3 here, so we got 13. Okay, now here's what I'm going to do with the numbers. I am going to subtract this 7 to the other side to set it equal to 0. So we have 27 that's positive, I have 16 that's positive, and then I'm going to subtract 7 from that. So if I do all that, I'm going to get 36. Okay, now, can anybody tell me two numbers, when you multiply them you get 36, you add them you get 13? 4 and 9, so plus 4 plus 9. All right, so the actual answer is what set those equal to 0? We'd have negative 4 and negative 9. Do either of those answers cause me a problem in the original question? Like, are both of those going to work? This causes you a problem because if you look right here, your two restrictions in the original problem, x could not be -8 or -9. Those would be the two numbers that would cause you to divide by 0. One of those numbers actually did end up being an answer. You still haven't, this is not a no solution, so -4 works, but the -9 does not. So -4 would be my only answer there. This would be an extraneous, the -9 would be an extraneous solution. Okay, I'm going to have you guys try C here. Just try C on your own. See if you can do it. It's pretty similar to the other two we just did. It's fine. She'll get -4. The main thing I saw, just a couple of you guys did this when you were going around. When you distribute this, because it's -3 times this x plus 2, should get -3x and then -6. I had a bunch of people that accidentally had a +6. So just like right here in this step, just make sure you distribute that like it's a -3. So then should end up, and however you combined it, I saw different people do different things. I just did one variable and one number on each side and then set it. So all my variables were positive. I got 8x equals -32, should be -4. Not a problem. That -4 is not something that would have been a restriction for either of those fractions in the original problem. Okay. Now, let's do one more. This one's kind of weird. So, I don't even have a fraction on the left side. So, there's different ways you could do this. What I would I'm maybe just going to think about it like this. Or, if you want to, you can literally just multiply both sides by x plus 1 because you get that out of the denominator. I just like to think about it as getting a common denominator. So, I'm going to throw my pen apparently. And all I'm going to do here, I'm just going to do x plus, or no, I'm not going to do it on this side at all. What am I doing? We're going to do x plus 1, and that would make those denominators match. It'd be the same algebra if you were to just multiply both sides by x plus 1 to get that out of the denominator. So I'm going to do a little FOIL here. The other side would just be 4. All right, you're going to get x squared plus x, so you're going to get plus 2x plus 1. Equals 4. Now, I promise, if you do end up with the quadratic, you can always use the quadratic formula, but if you want to, any quadratic you're going to be able to factor. So, this guy should be x squared plus 2x minus 3. Can we think of two numbers that multiply to get -3 but add up to 2? How could I get a combination of numbers that would multiply, get -3, add up to 2? What do you think? Yes. Do one as a +3, one as a -1. Okay, actual answers though. Opposite, or what makes that equal to 0. So this would be -3. This would be +1. And then just real quick, in that original problem, -1 would have caused me a problem. I did not get that, so both of those answers work. Does anybody have a question? Okay, let me flip this up. Alright, now we're just going to try and factor a little bit. So, don't worry about the top, just the bottom. So, what could I do to factor the bottom of that first fraction? I've got 2x squared minus 2x. Is there anything that you could take out in front? What do you think? 2x. Okay, what would you have left?
X minus.
Exactly. Yes, x minus 1. So if I'm going to divide both of those by 2x, you're good. This one, sorry, I'm just going to write it because we had the same one on the front. That's a difference, or that homework problem we reviewed. But anyway, that's difference of squares, x minus 1, x plus 1. And this guy actually has the same denominator as that one I just did, x minus 1, x plus 1. Difference of squares. Okay, so all I'm going to do is see what we need to make these match. Now, I have an x minus 1 in all three of these denominators, so we already have that. This one has a 2x. This one does not. So in the middle, I would need a 2x. Now, on this first one, I'm missing the x plus 1 that these other two have. So this would need an x plus 1. And the third fraction down here at the end is missing the 2x that that first fraction had, so 2x. All right, now each denominator there, you'd have 2x, x minus 1, and x plus 1. You don't have to FOIL that out or anything. As long as they all match, we're just going to cross it right on out, because if the denominators are equal, it forces the numerators to be equal. So we're just going to operate on the top. All right, now I'm going to actually, let me multiply this out. So you have 6x plus 5, and then you have x plus 1. So FOIL or box, whichever one you like better. I'm going to go ahead and write it all out. So if I do 6x times x, that's going to get us a quadratic. It'll be 6x squared. 6x times 1 is 6x. And then I'm going to do 5 times both of those terms in the other parentheses. So 5 times x is 5x. 5 times 1 is 5. And the top of that next fraction, 2 times, you're always multiplying when you do this. So 2 times 2x, so we'd have 4x. And then what would I have on the top on the other side? What would, if I simplified the top of this fraction, what would we have? Grace, what do you think? Yes, ma'am. Bless you. Okay, now, let me just do a little combined like terms here real quick. So I have 6x squared. On this side, you've got 6x, 5x, that's 11, and then 4 more. So I've got 15x plus 5, and then equals the 6x squared. The super nice thing here, if I subtract 6x squared from both sides to try and get all my variables on one side, these guys are going to cancel each other out. So you do not actually have a quadratic here. All right, so those are going to cancel each other out. What I have then is 15x plus 5. Since it canceled out, you don't leave a 1 there because we're not dividing, I would be subtracting, so this would leave a 0 here. So to get this solved, I would subtract the plain 5 to the other side, and then we would divide by 15 to get our answer here. And if you can reduce the fraction, you want to do that. So what would I reduce negative 5 over 15 to be? Negative 1/3, exactly. All right, and that's not going to cause you a problem in your denominator. Okay, now the last two have like a really weird quirk to them, but they won't be bad to do. It's just got like a little tiny trick. So if you ever see something like the denominator of this second fraction, where you have like, it's not in standard form, right? I have the constant first and then I have minus x. Okay, the intention here, if you see this, let me see what I can do. All right, if I have 4 minus x like this, not in standard form, you can, in any situation, you can do this. I can divide both of those by negative 1. All right, I'm not trying to get into this other problem, so let me cross that out there. All right, if I do that, be like a little negative 1 in front, it would change the 4 to be negative 4, and it would change the x to be positive. All right, now, typically, the way I would then write it if it was me, I would actually put that back in standard form. So you'd have the little negative 1 out in front, but then it would be x minus 4 would be in standard form. So if you see something like that, you got like not standard form, you got a negative in front of the x, your intention in that question is going to be, let's just pull out a negative 1. Okay, does anybody know how that would change the equation? Like if I pulled out a negative 1 and I started to write this problem. So I wrote the 2 over x plus 3, and now I know the bottom of this is going to be x minus 4. What would you put in between here? Anybody know? If I pulled out a negative 1, what would you put in between these two fractions? If it was originally a minus, and I'm going to pull out a minus, this would just, all that's going to do is change that to a plus. So like this negative here is just going to change up that sign in the middle. So if it was a positive, we'd change it to a negative. If it's negative, you're going to change it to a plus. So when I factor out the -1 here, I'm just dividing, and you don't do anything to the 3, just one part of the fraction. Divide out -1, it's just going to change the sign in the middle. All right, now, the other side here, and I know you can factor the top, but don't worry about factoring the top if you're solving an equation. You want to factor the bottom if you can, and then we're going to work on the top. So if you do this, now the factors here, multiply to get -12, add to get -1, end up being both of my denominators -4 and +3. So this is similar to some of the questions we were doing on the front side, where the two denominators are both in the denominator of one of the other fractions. So to make a common denominator here, we're not going to have to do a ton of work. We're not going to have a quadratic, but the reason I'm showing you this is just to factor out this negative. It's just going to change up the signs and allow you to get a factor that's pretty similar to what you have. So then this guy, that first one would need an x minus 4. This guy would need an x plus 3. And I don't need to do anything to the other fraction to make all those denominators match. All right, so just crossing that on out. Work on the top. If the denominators are all the same, it forces the numerators to be equal. You gotta do a little distributive property on both of these guys here. So I'm going to do 2x minus 8. We'll just distribute this 3. Should be distributed as a +3. So it'll be plus 3x. 3 times 3 is 9. And then the other side, you've got 2x minus 2. Now, I'm just going to combine like terms real quick here on the left. So 2x and 3x, you got 5 x's. -8 plus 9 is 1. And then however you guys want to do this. If it's me, I try to keep my variable positive. So I'm going to subtract 2x. And just right in the same step, just to save some space, I'm going to move that +1 to the other side by subtracting it. Excuse me. So I'm going to end up, let's see, these go. So you get 3x equals -3. So then what's x going to be? -1. And then just real quick check before you write your answer. That doesn't cause you a problem. We should be good to go here. Numbers that your x cannot be for this question would be 4 and -3 if I were to ask you for restrictions there. So that's not going to cause us a problem. So -1's our answer. Okay. Now I have kind of two like this in this question. So I've got a 3 minus x and I have a 4 minus x. Now, I don't have a quadratic anywhere here, but I would still tell you, let's factor out a negative, and then when we do that, it's going to make this easier to work with because we'll have this in standard form. Okay, so I'm just going to take a little -1 out of both of these terms, and I'm going to do that over here too. Okay, now on this one, I don't have anything in front of that lovely expression, so this would be like 7 over, you'd have like a negative out in front. This would become -3 plus x. And probably the easiest way then I could show you how to write that. I'm just going to put that negative just on the top. Totally legal, just put that little -1 on the top. So I'm going to make this -7. And I'm going to write the denominator then in standard form. I'm taking care of the negative, I just put it in the top. This would be x minus 3 then. Alright, I'm going to leave the 1/2 in the middle. Now, I'm going to do the same thing here. If I take a little -1, and if this is making sense to you, you don't have to write out all this work, but if I take a little -1 out of that other denominator that's not written in standard form, that would change that to -4 plus x. What I would do there, again, I'm just going to attach the negative to the top. If it had something added or subtracted, we could put it out in front, but we don't have anything added or subtracted to that, so it's just going to be -3, and this would be x minus 4. And it's just going to be easier for you to work with if you've got that in standard form. So that's all I'm doing is just practicing that little skill, just factoring out a negative. It's just going to switch the signs of what's in your denominator. So that way your x is positive. Okay, now this guy is going to need a 2, and it's also going to need an x minus 3. This guy has a 2. This needs an x minus 4 and an x minus 3 both. So we'll have to do a little FOIL on that. And then this guy is missing that 2 that we had here. And it's missing an x minus 4. All right, I did not write that in the best way possible. So let me come to the side here. All right, now I'm going to take the 2 and the negative 7. I'm just going to multiply that together real quick. So it'd be negative 14 times the x minus 4. Now, in between here, this is just 1 times this x minus 4, x minus 3. So we'll just do a little FOIL. And then on the end here, you had a negative 3 times 2. So I'm going to write minus 6 times the x minus 3. All right, so this one's pretty complicated. Oh, shoot, where am I supposed to have my equal sign? Okay, forget. This should be an equal sign in between there. And then that would be a negative 6. Sorry, that was supposed to be an equal sign. I just put minus. All right, now, let me do a little distributive property. This is going to be negative 14x. Negative times a negative, we're going to get plus 56. And then, let me do this above here. You get x squared minus 3x minus 4x plus 12 if you multiplied out with a little FOIL. So this would be, combine like terms, x squared minus 7x plus 12. And then the other side, don't forget, this was the negative 6. I just thought this was subtraction. I should put an equal sign there. This would be negative 6x plus 18. This does end up being quadratic. Let me just simplify this side real quick as much as possible. I have negative 21x, and then we got 56 and 12 on that side. So this is 68. On this side, I had negative 6x plus 18. If you have a quadratic, I would say when you're trying to set it equal to 0, keep your squared term positive. So I'm going to do this real quick. I'm going to add 6, and I'm going to subtract 18 when I set this equal to 0. So we're going to have x squared minus 15x, and what is that, plus 50 equals 0. Can you guys, this is a long problem, sorry, can you think of two numbers, when you multiply them, you'd get 50, and the same two numbers, you'd add them, and it would be negative 15?
Negative 5 and negative 10.
Yes, ma'am, negative 5, negative 10. Now, my two actual answers would be positive 5 and positive 10, and neither one of those is going to cause you a problem in the denominator. The two numbers you couldn't have your denominator be would be 4 and 3. We didn't get those as an answer. So this was a really hard problem here at the end. But just to show you that little trick a couple of times to factor out a negative. So if you ever see something that's not written in standard form, that's what they're trying to get you to do, is factor out a negative.